Arjun, thank you very much for joining me here. So tell me about Smart Joules. What do you do, and how do you fit in the entire sort of supply chain of being a good carbon citizen?
Right. Thanks for having me here. Smart Joules is basically building a utility of the future. We generally think of utility businesses like electricity and water and gas, but we are taking energy end uses like cooling, heating, and compressed air and turning them into a green utility. So these are three very large end uses. Almost every building and every factory requires to be cooled and heated, and they require pressurized air. But the way these services are currently delivered is completely broken. Energy efficiency is the last priority. People think about minimizing the first cost, and they don't realize that actually the largest cost in these systems is the life cycle cost, which is energy. 80 to 90% of the life cycle cost is energy. So Smart Joules puts the focus where it belongs, and we sell cooling, heating, and compressed air as a service. So we have projects across the country where we have reduced energy consumption by 35% in all of these systems on average. So that's what we do.
Right. So give me an example of either cooling, heating, or compressed air.
Yeah, exactly. Yeah. So typical example, let's take a case of a hospital. A hospital of 300 beds will spend anywhere between 4 to 5 crore rupees per year on energy, out of which about 60% is going to be for air conditioning. So what Smart Joules does is takes over the entire air conditioning system. We redesign it, retrofit it with the latest and greatest best-in-class technologies, and then automate the operations. We turn from human thumb rule based operations to completely automated data-based operations. So in doing so, we are able to reduce the consumption, that 3 crores per year that is going into air conditioning, to about 1.5. And what we sell to the customer is a percentage of the energy savings that we deliver. So we don't sell them equipment or services, we sell them energy savings. And we take all our fees as part of the savings that we deliver. This is our delivery to an existing facility.
Right. So when you talk about talk about cooling, if I were to pick up on that, so what is it that you're doing specifically? Are you reducing the number of hours, let's say, machines are running, or are you playing around with temperatures, or is it something else?
Yeah, a very good question. See, there's three things that we do primarily, three buckets. The first is excellent design. So we design the systems to be as efficient as possible. The second is choosing and investing in the best-in-class equipment, which is typically more expensive than your standard equipment. So a very simple way to think about it is, for your home, you may have a 3-star AC, but there are inverter ACs which are extremely efficient, maybe twice as much as a 3-star AC, but most people would shy away from that. We heavily invest in the best-in-class technology. And the third, which is the most important, we have proprietary technology to automate the operations. So if you think about it, your requirement for cooling is changing throughout the day, right? For this building, for example, in the afternoon, you'll require more cooling. In the evening, in the morning, you'll require less cooling. So what we do is automate the entire system, which matches the production of cooling with the demand of cooling. It also decides which equipment should be running, what should be the flow of water, what should be the set point of temperature, what are the combinations of equipment that should be running to keep you cool at a certain point of time. So by automating operations based on real data, we are able to reduce the demand by a very large, substantial fraction.
And the model that you've developed, is this something that could fit uniformly across kinds of cooling requirements, or is it like, would hospitals need a certain kind of algorithm, for example, and maybe a large mall require a different kind of?
So the good news is that you don't have to build every time. So every chiller plant, for example, is very similar. So what we do is we've got generic models that then figure out, based on real-time data, what to do with the system. So it's a self-learning system. So you develop it once, you configure it for the particular site. So the system does need to know what are the equipment installed over there, what are the design curves of the equipment. So there is a one-time upfront configuration requirement, not software development, just configuration of the software, and then it takes over. So that's what makes it extremely scalable in terms of the technology. Now, in terms of the business model, it's also very attractive for a large number of segments. We are currently focusing on segments that consume cooling 24/7, because that's where we make the highest impact for the end user. So sectors like hospitals, hotels, data centers, and pharmaceutical industry, and the food and beverage industry as well. So these are our primary targets as of the moment.
And it could be airports and so on as well. I mean,
certainly, we are certainly very interested to work with airports, and there's a couple of conversations going on.
Right. Yeah. And tell us about the other two. You talked about heating and compressed air.
Right. So compressed air is something that people don't usually think about. But I'll give you the case of a forging industry that we are working with. They require different types and different pressure set points for different machines. Now, there's one source of producing the compressed air, and there's about 100 machines that require compressed air. Now imagine, all of these machines require different pressure. They require pressure at different times of day. How are we producing and serving this requirement from a single source? So what we do is we dynamically understand which machine is on, which one is not on. And based on that, what are the pressure set points that need to be maintained and how much compressed air should be given to different areas. And then optimize the compressor plant to actually produce what is required, when it is required, and distribute it. So, here again in compressed air, similar to cooling, we have been able to see savings of 35% for an existing plant, which was already pretty efficient. And compressed air is something that every industry uses. The cement industry, heavy consumer, like one cement plant that we are talking about right now, it has 72 compressors across the plant for various applications. Forging industry, steel industry, the automobile industry, almost every industry requires compressed air, and it is very typically ignored. It is a utility, but it doesn't have a utility.
Yeah, and when you go to a shop floor, you also hear compression all the time, right?
That's right. And you can see the leakage of compressed air. It's very
Yeah.
easy to leak. If there's high pressure, imagine 6 bar, 7 bar pressure in the line, and people misuse it, right? So you have to look at it holistically. What are the right equipment? What are the right control mechanisms? And careful monitoring and automation. Extremely important with compressed air.
So cooling and heating somehow are connected.
Right.
How did you think of compressed air as another?
Very good question. See, what we found is that the basic characteristics of these three systems are the same. One, there is one centralized source of generation. For cooling, it's a chiller plant. For compression, it's a compressor plant. Second, there is a distribution line. So chill water, hot water, compressed air, they have to be distributed to the end users. Lastly, there is a dynamic requirement which is distributed in many locations. So the requirement of cooling, of heating and compressed air is always changing. What does that mean? That means thumb rule based human operations is not going to work. That means if you have data based, software based, continuous tweaking of the generation side, which is complex, and the demand side, which is variable, then you're going to find massive opportunities for operational efficiency improvement. That's on one hand. On the other hand, all of these are MEP services. So we don't have high quality, excellent energy efficient design in this country at all. So all three of these utilities really suffer from poor MEP design. So,
what is MEP?
Mechanical, electrical, and plumbing.
Okay.
It's basically who designs the system of compressed air, right? So we found these two issues, right? One is huge opportunity in operational savings. Second is huge opportunities in design. And the basic fact is that energy in all of these systems is 80% of the life cycle cost. So if we are able to reduce that 80%, then we become the lowest cost producer of cooling, heating, and compressed air. And that allows us to build a utility business model where we just sell cooling, heating, and compressed air. Energy efficiency is difficult to sell, but cooling, heating, and compressed air, which is efficient, is much easier to sell and much faster to scale.
Right. And how is Smart Joules, I don't know if transitioning is the right word, but as you've embarked on this as a product offering, is this what's the evolution for you as you go along in coming months or years?
Well, the evolution is to sign up a large number of corporates across their facilities. The trick here is portfolio-wide agreements. So we need to convert large corporates to accepting the model of cooling, heating, and compressed air as a service. And the good news is that they are fed up with the way that these systems are currently running. They are expensive, they are unreliable. When there is a problem, there is finger pointing with the 10 agencies that are currently managing the system. And they know it is expensive, but they don't know what to do about it. So we have already converted 2 very large corporates into cooling as a service, and we are on track to scale up fast. I think the limiting factor here is how quickly we can scale up our execution capabilities. The demand is there in the market, the money is there in the market, everybody wants to invest in this because these are very profitable investments. The other thing about energy efficiency, it's the most profitable way to fight climate change.
Right.
So there is money around, there is demand around. What we need to do is scale up our execution capacity so that we can service the demand that is out there and do multiple projects at the same time.
Right. So last couple of questions. So, we see the retail version of what you're saying, like with Nest and so on. Is that something that you're also thinking of, or are you mostly an institutional and going to be an institutional player?
We don't think that we're going to go to the residential sector directly. We do think that partnerships are a way to do that. So we have a technology which allows for continuous optimization, right? So we are talking to some utility companies which are already servicing the residential players to leverage the technology and bring it to them. I don't think we're going to get into directly reaching out to the customer and doing all of that, because that is a huge infrastructure, and the ability to sell and service a large number of distributed customers is something that we don't want to build.
Sure.
It's already existing with utilities. Utilities are already thinking about how to reimagine themselves, right? Your electric utilities right now thinking about how they can bring innovative services to their customers. So that's the channel through which we would reach your house. But that would be a future plan. Right now we are focused on the large concentrated energy consumption which happens in big buildings and factories.
Yeah, and that's a huge opportunity in itself. So,
That's right.
So what made you look at this particular space, or how did you start this up?
Well, it goes back to my first job. My first job was in Lawrence Berkeley National Lab, and the topic of the project was Bijli, Berkeley, India Joint Leadership in Environment and Energy. So my first research report found that India can completely eliminate the electricity deficit. That time we had 300 million people without reliable energy access. So my report found that we can provide 24/7 electricity access to all of these people without building a single new power plant. All we needed to do was to eliminate energy waste. But what we did in the decade that followed is we built 140 gigawatts of new coal-fired power plants. We can't do that again. We have to act this time. So I decided to start this company to actually work on that issue that I had identified in my first job. That's what drives me to make this happen.
But so you started out as a researcher at the Lawrence Livermore.
Right. Okay. Yeah, Lawrence Berkeley National Lab.
Okay.
Started off as a researcher, then went to study a little more, learned about entrepreneurship. Started a company in the US, was part of another startup to see how a company scales. Then came back to India and saw the problem really on the ground. I joined a very large company, JP Group, in the chairman's office. Got to see all the facilities and what is the energy waste looking like, how do we address it.
Cement.
I spent a lot of time in cement plants, in hotels, in their one hospital, real estate, all their businesses, fertilizer, to see what can we do, right? How can we profitably decarbonize? And I found potential and opportunity everywhere. So that's when I thought, while the whole world is focused on renewables and storage and EVs and all of that, I can create a huge multi-billion-dollar business on the demand side of the equation. How do we reduce waste? And that's what the journey that we're on right now.
Right, and I do wish you all the best. So last question. So what would you want to take away from a gathering like this?
I would want the business cards of all the leaders that are out here, and I would want to convert them into accepting the model of buying cooling, heating, and compressed air as a service.
Right, that's a wonderful pitch. Thank you so much.